Welcome to Ask and Learn.
Problem 23.40. So we have a sheet of charge that's some distance d to the left of a point charge q at the origin. And what we'd like to do is find out what are the positive and negative x values where the electric field will be 0 if the distance d is 0.2 meters, and then what if it's 0.8 meters. Now, measuring the distances along the x-axis from the point charge, the actual distance from the point charge is always going to be the same. So regardless of where this is located, if it's possible for the 0 points to exist, they're going to be here or here. And the only thing, because the field from this is constant everywhere, or there's a change in sign if it moves over to the right of the charge, but it's sort of the same story. So what happens is that if one of these points where the 0 has to be is in fact in between the two, the charge is positive, so its field lines are coming out like this. This is negative, so field lines have to go onto it like this, and so these can't go, the value of the field on these lines can't go through 0 because it doesn't change direction. So basically, if the points we get are inside of this region, then those points can't actually be valid solutions for a given separation between them. And so basically, the magnitudes of the electric fields being equal is the condition that holds at these points where the field goes to 0, obviously, because one is directed in one direction, the other is directed in the other direction. If it's outside of, if it's over here, they're directed in the same direction in here, which is the problem, but or the potential problem we might run into. But none of this depends on the separation d, because again, the field here has a constant magnitude. So r, which will be our x-coordinate, so we only are curious about this on the x-axis. It'd be a little more difficult if we wanted every point in space. I mean, that would be, you'd get some weird shapes that would be loci of points of 0 electric field. So then this will be plus or minus the square root of 3 over 2 pi. Or 3/2 pi. Anyway, wait. Yes. I forgot a pi here. I think it's 3/2 pi. Anyway, so this is 0.691 meters, plus or minus. So in the case where this is 0.2 meters away, 0.691 is way off, on either side here. So we get positive 0.691 and negative 0.691 meters. Now, if the separation is increased, what happens is that we've moved this plate back beyond where this is, and so it can no longer exist. So in this situation, only the positive 0.691 meter 0, it can exist.